Section: Introduction. In this section, we discuss the significant impact of ChatGPT's release in November 2022, which led to a surge in interest regarding post-training methods and preference optimization strategies for supervised fine-tuning. Many recent studies primarily use LLM-judge benchmarks like MT-Bench, Alpaca Eval, and Arena Hard Auto for evaluation. These benchmarks utilize LLM judges to automate assessments while aligning with human preferences, becoming standard due to their effectiveness in predicting desirable model behaviors. Authors of recent papers often claim improvements in areas such as instruction following, harm reduction, reasoning enhancement, response accuracy, and overall language generation quality based on these benchmarks. However, these claims rely on the assumption that the Bradley-Terry model, which focuses on pairwise preferences, will naturally lead to these improvements. We question whether LLM-judge preferences truly translate to tangible progress in alignment metrics and explore the reasons if they do not. Our contributions include establishing a framework for evaluating LLM-judge pipelines and identifying potential biases at each stage. We discover that LLM judges exhibit strong implicit biases, favoring stylistic preferences over critical alignment factors like factual accuracy and safety. To complement existing benchmarks, we introduce SOS Bench, a new alignment benchmark grounded in principles of helpfulness, honesty, and harmlessness. We also conduct what we believe to be the largest controlled meta-analysis of publicly available post-training methods, revealing that data scaling during the supervised fine-tuning stage and prompt diversity are key predictors of improved alignment. We conclude with practical recommendations for the research community. In terms of post-training, we define it as all updates made to the model after the initial pre-training phase, aiming to transform a text completion model into a functional AI assistant. This process typically involves two stages: supervised instruction fine-tuning and preference optimization. LLM judges are LLMs tasked with generating decisions about content, particularly focusing on approximating human preferences in model outputs. We identify two main trends in benchmarking model alignment. The first involves creating large test sets with ground truth answers to evaluate models, as seen in benchmarks like Stanford's Helm and Hugging Face's Open LLM leaderboards. The second, more prevalent method, focuses on LLM-judge benchmarks, which we explore in detail. We note that the use of LLM-judge benchmarks has rapidly increased since 2022, with a representative sample of 19 papers showing that 80% benchmark exclusively on pairwise preferences, a rise from 50% in 2023. This trend prompts us to examine the properties and design of these benchmarks more closely. We find that while LLM-judge scores correlate well with each other, they do not align consistently with static benchmarks. To better understand these discrepancies, we introduce a framework for comparing LLM-judge benchmarks. We highlight key differences between LLM-judge benchmarks and traditional NLP benchmarks, noting that LLM-judge benchmarks require a judge, which introduces significant confounds. Additionally, LLM-judge benchmarks are comparison-based rather than reference-based, and they often cover a broader range of subjects with fewer questions. We also point out that LLM-judge benchmarks must specify both metrics and judging criteria, which can lead to potential confounds if the instructions are unclear or not aligned with best practices. Implicit biases in judges, whether explicit or inherent, can affect the outcomes of preference selection tasks. We argue that an ideal LLM-judge benchmark should aim to make biases explicit and minimize implicit biases, and we dedicate the next section to exploring implicit bias in LLM judges. Section Summary. In this section, we discuss the surge in interest surrounding post-training methods and LLM judge benchmarks since the release of ChatGPT, highlighting their limitations and biases, particularly in prioritizing stylistic preferences over crucial alignment factors like factuality and safety. We propose a new alignment benchmark, SOS Bench, and emphasize the importance of data scaling and prompt diversity in improving alignment, while also outlining the need for a systematic evaluation framework for LLM judge pipelines. Section: Implicit bias in LLM judges. In this section, we explore implicit bias in LLM judges. We might assume that when given a set of judging criteria without specific instructions on how to prioritize them, LLMs would treat all criteria equally. However, our findings reveal that this is not true. Instead, LLMs show significant implicit biases, reweighting criteria in ways that often overlook some while highlighting others. Additionally, within the criteria, certain types of violations are penalized more severely than others. For our experiments, we use various models, including post-trained Llama 3 to 8B base models and others, all of which are available on Hugging Face. We focus on the Arena Hard Auto benchmark because it is widely recognized and claims strong alignment with human preferences. Unless stated otherwise, we adhere to the standard settings for this benchmark, using specific GPT models as baselines and judges. Due to cost considerations, we substitute one model for the standard judge in some tables. We also modify the judge template, which we detail in an appendix. When we provide explicit judgment criteria, we find that LLM judges implicitly reweight them. We instruct the judge to express preferences based on 5 specific criteria: completeness, conciseness, style, safety, and correctness. Completeness and correctness evaluate honesty, safety measures harmlessness, while completeness, style, and conciseness assess helpfulness. Our results show that scores for completeness, style, and the overall score are nearly the same, with correctness ranking similarly but showing more variability. Safety scores are consistent across models, while conciseness tends to be inversely related. We observe that LLM judges implicitly favor completeness and style. This explains why an 8B fine-tuned model ranks higher than GPT-4. It produces verbose and overly polite responses, which we refer to as stylistic reward hacking. We also investigate how LLM judges weigh different criteria violations. We introduce systematic violations in the responses of the top-performing model and reassess its scores. Our goal is to see if the model understands the explicit instructions and how it prioritizes violations. We provide examples of these altered responses in an appendix. For our interventions, we use GPT-4o Mini, ensuring factual claims remain unchanged. We create various interventions, one that makes responses repetitive, another that alters a key fact, a concise version that compresses responses, and a sarcastic version that rewrites responses in an irritating tone. Our results indicate that LLM judges are particularly critical of unconventional stylistic changes, like sarcasm, while being more lenient towards significant factual errors. This raises questions about whether these implicit biases align with our priorities in model alignment, as sarcasm is a minor issue compared to incorrect answers, which violate honesty more severely. Section Summary. In this section, we demonstrate that LLM judges exhibit implicit biases by reweighting judging criteria, often favoring completeness and style while being lenient on major factual errors compared to unconventional stylistic changes. Our experiments reveal that these biases may not align with our intended priorities for model alignment, as LLMs score harshly on minor stylistic violations while overlooking significant inaccuracies. Section SOS Bench. In this section, we introduce SOS Bench, a new set of objective measures to track progress in alignment, which can help our research community advance more quickly. We have identified and combined 19 existing benchmarks that assess various aspects of large language model, LLM, behavior and performance, creating a comprehensive meta-benchmark. The name SOS Bench reflects our findings that more data leads to better alignment. We provide a complete list of the benchmarks in a reference table. Each question in our benchmark has a correct answer, and we report results using the average of normalized accuracies, along with confidence intervals. We evaluate models on over 152,000 data points, which is nearly 7 times larger than the previous largest open-source LLM benchmark. While other model releases provide meta-benchmark results, they often lack reproducibility and can be biased in their result aggregations. By standardizing our approach and increasing the scale, we aim to establish a reliable measure of alignment. We break down our benchmark into 3 key areas: world knowledge, instruction following, and safety, and we also compare our results with those from another benchmark. We recognize that no single measure can encompass all important factors, but we focus on a subset of tasks based on the helpful, honest, and harmless principles, which are widely accepted. We propose that if one model performs better across all 3 areas compared to another, it is better aligned. We present some notable trends from our experiments with SOS Bench. First, we find that increasing data size improves alignment during the supervised fine-tuning (SFT) stage of post-training. Contrary to some recent findings, we show that the amount and diversity of data are the strongest predictors of performance, rather than the curation methods. While all alignment measures benefit from data scaling, the improvement is particularly significant for instruction following. Next, we observe that specialized post-training methods do not perform as well as generalist methods. Our tests indicate that focusing on narrow tasks without diverse prompts leads to poorer overall performance compared to a more general approach. Additionally, we find that preference optimization can lead to a trade-off where world knowledge may decrease in exchange for better safety and instruction following. Although we see improvements in the latter 2 areas, they are not as substantial as those observed during the SFT stage. This degradation in world knowledge aligns with previous research, and we note that the choice of datasets and optimization algorithms can significantly impact results. In conclusion, while our research into preference optimization shows promise, we recognize the need for more thorough and careful benchmarking to ensure the reliability of our findings.